Hello everyone, last time we already introduced the operation method of MLPA-NGS technology. Next, I will take the results of the PD kit as an example. To introduce the usage method of MLPA-NGS analyzer. First, log into our official website. Click on the Download Center and download the MLPA-NGS analyzer software. Double-click to open the software. Register an account and password. After completing the registration, close the page. Double-click to open the software and enter the login page to log in. Click to enter the main program. After entering the main program, you can see three options: FastQ Analysis, CNV Analysis, and Help. The default interface is the FastQ Analysis. First, users import FastQ sequencing files for analysis via the FastQ Analysis button. The analysis is completed, and result files will be exported. One is an MLN file, and the other is an Excel file. MLN files are for machine reading, that is, for further analysis by the CNV analysis module. Excel files are mainly for human reading. Multiple FastQ files can be input for each analysis, and a MLN file and an Excel file will be generated. Kit. Users should select the corresponding kit for analysis, based on the kit they used for testing. Sequencing folder path. Here, users select the folder where the FastQ files to be analyzed are located. File name signature. After entering words or phrases in the text box and clicking search, the system will only search for files whose names contain these words or phrases. Project file save path. Project files refer to MLN files and Excel files. The default save path is the same as the sequencing folder path. If a new path is selected, it will be saved to the corresponding path. Project file name. The default project file name is the kit name plus the time when the analysis is completed, the suffix MLN, or the XLSX of the Excel file. If a new file name is entered, it will be saved with that name plus the suffix. We have chosen the PT results for interpretation this time. Click on the sequencing folder path to select the FastQ file that needs to be analyzed. For our samples, the outsourcing sequencing service we chose is bidirectional sequencing. Each sample will return to sequencing files, one for the forward direction and one for the reverse direction, labeled R1 and R2 respectively. Our software can only analyze R1 files and cannot analyze R2 files. Enter R1 in the file name signature to filter files whose names contain R1. In the lower left corner, users can select the sample that needs to be analyzed. Can select all. The selected samples can be cleared, or clear the selected samples with one click. You can also select several samples individually. After selecting the samples we need to analyze, the save location, and the name, we can start running it. The running time depends on the size and number of FASTQ files, as well as the user's computer configuration. During the running process, the progress of the operation can be displayed here. Users can roughly estimate the running time based on the progress here. After the operation is completed, we can obtain machine-readable MLN files and human-readable Excel files. Click on CNV Analysis to enter the Project File Analysis interface. Project Path. Users can select the MLN file to be analyzed here. After selection, click Open Project, and the interface will display the relevant chromosome information after each file name. You can also close the current project data and open another project data. The file names displayed in the left list are the sample numbers at the time of submission. Click the Display button on the right. The sample of the selected radio button here will be displayed on the right side. A, X, Y represent autosome, X chromosome, Y chromosome respectively. Green represents qualified, red represents data abnormality, and brown represents the critical zone. The ratio of Y to X represents the dosage ratio of the Y chromosome to the X chromosome. Blue represents a ratio around 1, which is judged as male. Pink represents that the ratio is around 0, which is judged as female. Brown represents the critical section. Grouping is to divide samples into different families, making it easy to distinguish samples from multiple different families. In the drawing mode at the top right, you can select either a CNV chart or a Reads chart. The family lines that can be detected by the PT kit include parent-child FMC, parent-child PC, brothers BB, sisters SS, and uncle-nephew 1. These 12 samples correspond to 4 families respectively. The arrangement order of each family is child, father, mother. However, we must pay special attention when selecting families. The selection order should be consistent with the order above. Therefore, it is necessary to first check the father sample, then check the mother's and the child's samples in sequence. After checking the boxes, click Display on the right, and the corresponding SNP loci for each sample will be displayed. If the order of parent and child is checked incorrectly, the SNP results cannot be displayed. Here is the name of the kit. The second line is the file name of the sample. The third line contains the numbers of the control samples used. The fourth line is the name of the MLN file. SNP signature is the merging of 16 SNP into 8 numbers. These 16 representative SNP of each person are generally not completely the same, and can be regarded as the characteristic code of the person's genetic material, which is convenient for distinguishing samples. There are Show Previous File and Show Next File buttons at the bottom of the interface. These two buttons allow for quick switching between the samples that need to be viewed. The Save the Figure button can save the bar chart on the current page. The Configure Subplots button can adjust the shape and size of the current page. The Zoom to Rectangle X or Y Fixes Axis button can zoom in on local information. The left button pans, right button zooms X or Y fixes axis, control fixes aspect button, can perform the shortcut operations of panning with the left mouse button, and zooming with the right mouse button on the page. You can also use the left and right arrows below to back to previous view or forward to next view. Clicking this button can reset original view. The function of save image below is similar to the save the figure above. The move horizontally on the right side is to facilitate users to move the interface after zooming in left and right. Zoom horizontally refers to scaling in the horizontal direction. When the probes are dense, it is convenient for users to analyze the probes. Clicking the reset button can restore the original state. Click on Reads Data or CNV data in the drawing mode to get specific data for each locus. A better way to check the number of reads is to browse the Excel file obtained from data analysis. The CNV data will change as the selected control sample changes. The red 1C position indicates the current sample of the current pedigree, and the right side shows the result of each SNP. Below 1C are 1F and 1M, and the order of C, F, and M is consistent with the order of the samples on the left. FC, MC, and FMC respectively indicate whether the father and child, mother and child and parents are in line. Meet the display of green V. Does not meet the requirement, showing a red O. Among these SNP, the bold ones represent the wild type, and the non-bold ones represent the mutant type. Most of the horizontal lines above the two alleles are green, indicating that the SNP quality control has passed. Red indicates that the quality control has failed. Two alleles are connected by a vertical line, and the position of the horizontal line on the vertical line indicates the proportion of wild-type reads to the total number of reads for that SNP. These are 12 candidate SNP loci, used for quality control of SNP loci. If a control is selected in the sample, the CNV information of autosomes, X, and Y chromosomes can be displayed. This kit is mainly used for SNP detection, and CNV is for reference only. When selecting control samples, healthy male samples should be chosen, because female samples lack Y chromosome information and are not suitable as controls. When users choose to analyze parent-child relationships, they can separately check father and child or mother and child. After checking the boxes, click Display on the right, and the corresponding SNP loci for each sample will be displayed. Brothers' Y chromosomes are all inherited from their father, so their Y SNP loci are completely identical. However, since the Y chromosome follows paternal inheritance, all males belonging to the same paternal family, such as father and son, uncle and nephew, grandfather and grandson, will have the same Y SNP. Therefore, it is impossible to distinguish between brothers and other paternal relatives solely based on the consistency of Y SNP. We randomly selected two male samples from two families for comparison. Multiple red circles can be seen in Y SNP, which rules out the possibility that they are brothers or uncle and nephew. Sisters inherit one X chromosome from their father and the other from their mother. The X chromosome from the father is an identical single chromosome, so they will share at least one identical allele at any SNP locus on the X chromosome. Since this kit is mainly focused on parent-child relationships, there are relatively few SNP loci related to other genetic relationships, and the results are for reference only. In addition to conducting kinship analysis, our kit can also perform paternal ancestry analysis using 114Y SNP loci. This function is only applicable to male samples. The Y chromosome is unique in being passed from father to son. By detecting stable SNP mutations on the Y chromosome, you can trace the origin of a person's paternal ancestors and understand the migration routes of the family and history. All the loci used for ancestry analysis in our kit are included in this table. We can find out which of these 114 SNP loci have mutations, based on the position information corresponding to each locus, and then determine where the user's ancestral origin is based on the mutation information. For example, the site mutations detected in this sample include M to 14, P191, F for 00, etc., red-marked area. According to this table, we can see that their types from major categories to subcategories are NO, O, O2, etc., enabling relatively precise ancestral origin analysis. The O type has a specific distribution in East Asia. Currently, our software can fully display the detection results of each male sample at 114Y SNP loci, but it is still necessary to manually query the haplogroup to which each mutation locus belongs. We are developing an automatic analysis function. Future versions will be able to automatically calculate haplogroups and generate ancestry analysis reports, making the analysis results clear at a glance. The above is the complete interpretation process for the results of the PT reagent kit. Thank you all for watching. If you have any questions, please feel free to contact us at any time.